An IC engine operating on dual cycle. Dual cycle is also called limited pressure cycle. So there two types of heat addition takes place. One is at constant volume, another one is constant pressure. The temperature of the working fluid, it is air as a working fluid because it is air standard cycles. We are assuming it as air standard cycles. It's air. At the beginning of the compression, the temperature is 27 degrees Celsius. So first you write what is the type of cycle? It is dual cycle. So in the regular classes, I have told you, one identify the cycle first, then you draw PV diagram. So this is a PV diagram I will take here. Then we have written. So this is a PV diagram for dual cycle. So in this PV diagram, the temperature at the beginning of the part is here. That is T1. Write down T1 is equal to 27 degrees Celsius plus 273. It convert into Kelvin. Okay. And I will be explaining only the procedure. My dear students, it's my request to you to take the calculator and do it individually. The ratio of maximum and minimum pressure in the cycle is 70. So in this PV diagram, maximum pressure is P3 or it is also equal to P4. And minimum pressure is 1. What he has given, maximum and minimum pressure of the cycle is 70. Maximum pressure is P3. Minimum pressure is P1. That he has given as 70. Compression ratio is 15. Compression ratio will be represented with RC. That is total volume of the cylinder. From here to here it is total volume. And here to here it is clearance volume. So total volume divided by clearance volume. That is VC. Total volume is V1 by VC. It is equal to 15. Okay. Next. Read the next line. What he has given. The amount of heat added at constant volume means which process it is at constant volume, that is 2 to 3. So heat added during 2 to 3, that is heat supplied at constant volume and at constant pressure, both are equal. So whatever the heat they have added here during these two processes, both are same. So I will write heat supplied at constant volume is equal to heat supplied at constant pressure. That is what he has given. The amount of heat added at constant volume. So that is 2 to 3. From here to here it is 2 to 3 constant volume. And at constant pressure. From here to here is constant pressure 3 to 4. So that is both are equal. Compute the air standard thermal efficiency of the cycle. So efficiency of the dual cycle you need to find out. State 3 main reasons why the actual thermal efficiency is different from the theoretical value. This is second part of the numerical. First you will try up to here. And one more data he is given that is important. Adiabatic index, that is 1.4. So I will write gamma is equal to 1.4. So this is the data. So I hope you have copied in your notebook so that because I'm going to next page, you must remember the values. Okay, next now. We will write what? Step 2, efficiency of the cycle. There are two types of equations you will get. One is in terms of heat supplied minus heat rejected divided by heat supplied. This is one term, one in terms of heat supplied. Okay. Next one. One more is in terms of temperatures. Okay, that is also in terms of temperatures. All terms will be getting temperatures. That I will write here. One more equation as we discussed in the previous class. Efficiency in terms of cutoff ratio, compression ratio, and gamma. That is a big equation what we have solved in the previous classes. So instead of using this equation, let me try using these three terms. So first I will write the formula for QS. QS is nothing but heat supplied at constant pressure and constant volume. So there are two types of heat additions. As you see on the board here, there are two types of heat additions. Let me remove this so that you can understand better. Yes. Now, so this is also a heat addition. Yeah. Here is 2 to 3 is heat addition at constant volume. 3 to 4 heat addition at constant pressure. So first I will write the equation for constant volume. Okay, that is Qs is equal to, you know the equation, m Cp delta T, but here it is not Cp, it is Cv. And temperature difference between these two, that is for heat supplied process, highest temperature minus lowest temperature. So I will write it is T3 minus T2. This is the one equation. One more heat is supplied at constant pressure. I will add here only because that will give the total heat addition. MCP. Okay, you write here MCP. I will get MCV. It is not there now. Second process is CP, and look at the process during 3 to 4. Temperature at point number 4 will be more than point number 3. Already we discussed how to draw the TS diagram in the previous classes. Please remember, go to previous classes and understand how to take the values. Here I am going to write T4 minus T3. This is QS. And heat rejected is 5 to 1. That I will write QR is equal to M. Now identify what type of heat rejection is it? Heat rejection is constant volume or constant pressure. So this one is constant volume. So I will write MCV T5 minus T1. Now, as I said here, all temperatures are, you need to calculate T1, T2, T3, T5, T4, T3. Once you calculate all the temperatures, substitute in this equation, then you will calculate the remaining one. So I will substitute these equations now because I need to write in terms of temperatures. So what is total heat supplied here? This is the equation, right? M. With your permission, can I write like this? It will become easy for me to solve the numerical. 1 minus QR by QS. If you take LCM here, 1 minus QR by QS. So what I do is, I will remove this. Okay. So I will take 1 minus, what is the equation for QR? You are written here, MCV T5 minus T1 divided by, what is the heat supplied? Here is the heat supplied, MCV T3 minus T2 plus MCP T4 minus T3. And dear students, as we know that mass is always 1 kg, and unless given the numerical, we'll assume it is 1 kg. So here this M, and this M get cancelled. You take the common in the denominator, and it will cancel with the numerator M value. Okay. Next, our aim is to find out T5, T2, T3, T4, T3. This is given. So T1 is 27 degrees Celsius plus 273, that will be 300 Kelvin. Okay, now compression process. I will draw the simple diagram here. Up to here, 1 to 2 is a compression process. So what type of compression process it is? What type of compression process? It is a isentropic compression. So we know the equation T2 by T1 is equal to V1 by V2 to the power of gamma minus 1. Here T2 is unknown. So T2 is equal to, T1 is given as 300, that you write to take multiplier. V1 by V2 compression ratio, it is given in the numerical 15 to the power of, how much is the value of 1 gamma? That is 1.4 minus 1. So now T2 is equal to, so please anyone tell me answer for T2. How much will you get? Please unmute yourself and you can answer. Otherwise, I will write the formula 886. This is what I got. Please cross check. 886.25 Kelvin. And keep in mind, once you calculate T2, T2 should be more than T1. Next, now how we calculate T3? How to calculate this T3? What is the name of the process? 2 to 3 constant volume. So during constant volume, you need to write one equation, ideal gas equation. Understood? So I will write here. So during 2 to 3, it is a constant volume heat addition. So once you identify the process, constant volume is nothing but, and apply ideal gas equation. Tonight I will write PV is equal to MRT. I'm going to apply this equation 0.3 as well as this equation I will write at 0.4. So once you apply 0.3, P3, V3, T3. I will apply this equation P4, V4 and T4. You take the ratio, and during 2 to 3, this 2 to 3 process, it is constant volume. So these two get cancelled. So left is P3 divided by P4 is equal to, and these two also get cancelled. So T3 divided by T4. But we don't know T3. But we have calculated only T2 and we know T1. But we don't know T3. We know P3. Okay, how to calculate this value? Any idea? Anybody please help me? Write down this equation. One more. We know the process 1 to 2. 1 to 2 is what type of process? Isentropic. One more equation you can apply for isentropic. P1 V1 to the power of gamma is equal to P2 V2 to the power of gamma. Yeah. So here V1 by V2 is given, right, in terms of P1 by P2. Just I am trying to find out the value of these two. We know the ratio P3 by P1 we know. Understood? So first I will calculate P1. That I will substitute here. Then you need easy. So here P1 by P2 is equal to V2 by V1 to the power of gamma. Calculate P2. So using this equation, how will you write the P2? P2 is equal to P1 divided by this term V2 by V1. I can write 1 divided by V1 by V2. That is 1 by RC, because compression ratio is V1 by V2. So P1, how much he has given? We don't know. As it is, right. Simplify this equation. I will get it as 44.3 P1, because I don't know P1 also. Okay, so I'm writing P2 in terms of P1. So once you write the equation for P2 by P1, apply one more process. At ideal gas equation at 0.3 or at 0.2. That is during 2 to 3 process, my dear student. Try to understand 2 to 3. Okay, so here during this constant volume is there, so you'll get in terms of temperature. One more equation we can write. PV is equal to MRT. Here volume is constant, mass and R is constant. So I will take P by T is equal to constant. This is the same formula. How we have written here. Same is writing here. So I am writing at 0.2. P2 by T2 is equal to constant. This is also equal to P3 by T3. Okay. So now using this equation, you calculate P2. P2 is equal to T2, P3 divided by T3. Okay. Why I'm using this? I need this ratio. Okay. And T2 I know. So how much is the value of P2? P2 is in terms of P1 that you write here. P2 is in terms of P1 that you substitute here. 4.44.3 P1 is equal to T2 by T3 you write as it is, because I don't know. P3 also you write as it is. And using this equation, you know the ratio P3 by P1, maximum pressure to minimum pressure, he has given 70. So this term you take on the right hand side. Okay, so it will be P3 by P1 is equal to T3 by T2 into 44.2. So this ratio is given as 70. Substitute 70 T3 by T2 into 44.2. And dear students, in the above step, you have calculated T2. Now calculate T3. Because here in the step number 2, we have calculated T2. If you go to the previous, here we have calculated. So we are applying just only ideal gas equation for all processes. So T3 you will get as 1400. So now you have calculated T1, T2, T3. So now it is left to calculate only T4 and T5. So now, dear students, one equation he has given: heat supplied at a constant volume, that is mCv T3 minus T2. This is equal to heat supplied at constant pressure. It is given in the numerical. This is the condition he has given. Heat supplied at constant volume is equal to constant pressure. Let me go to first page and I will show you what is the data he has given. See here we have done here. Heat supplied at constant volume is equal to constant pressure. This is the data. So using this equation, using equations of heat supplied, I am writing this equation. Just so m get cancelled. So T3 minus T2, Cp by Cv, T4 minus T3. Cp by Cv is what? Gamma. T4 minus T3. And here T3 minus T2. And dear students, you have calculated T3. T3 is known. T2, T3 both are known. In the previous step, you calculated T2. Here you have calculated T3. T3 is known. Gamma is 1.4. Only unknown is T4. That T4 is equal to, tell me the value. So you may get 1765 Kelvin. That is what I have calculated. And please check your calculation part. And T4 should be more than T3. Okay. Now you have calculated all the temperatures. You calculated all the temperatures. We'll go back to the efficiency equation. See here. T1 you have calculated. T2 you have calculated. T3 you have calculated. T4 you also have calculated. And T3 also you have calculated. Only left is T5. So T4 to 5, this 4 to 5 process is isentropic expansion process. That equation I can write now. You know the equation. So T5 divided by T4 or T4 by T5. Anyone you can take. T4 by T5 is equal to V5 by V4 to the power of gamma minus 1. Here T4 already were calculated, only unknown is T5. But do you know V5 and V4? That is a challenging. Okay, I will write that expression once again here. So during 4 to 5 process, it is isentropic expansion. So T4 by T5 is equal to V5 by V4 to the power of gamma minus 1. Here I need T5. T4 is already known, but V5 and V4 we don't know. V5 is also equal to V1. I will write V1 because I will draw the diagram here. I will not go to the previous. So this is 1 point, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So here it is V5 is equal to V1 because it is constant value heat rejection. So I will write V1. Now V4 we don't know. But I told you in the previous class, just multiply and divide with some term. I will, this 3 is an intermediate volume. So I will multiply with this So 1.4 minus V3 and multiply and divide. So equation will be remains same. So V1 by V3, V1 by V3, V1 and V3. So V1 is total volume, V3 is clearance volume. So V3 is equal to V2. Look at the diagram here. Volume is constant during 2 to 3. So I can write V1 by V2 also. V3 by V4, the cutoff ratio is V4 by V3. So I need here V3 by V4. So V3 by V4 is equal to 1 by rho. That I will write 1 by rho here to the power of 0.4. Okay. So question is, has a given rho? No. So T4, T5, both are unknown. T4 is known. T5 is not known. So T5 is equal to how much we need to find, but we don't know rho, that is cutoff ratio also we don't know. So to calculate cutoff ratio is related to which process? Let me go to the previous PV diagram and I will show you. Cutoff ratio is constant pressure. Yeah, from here to here it is cutoff ratio, that is V4 by V3 is cutoff ratio. This is cutoff point. This is beginning of the cutoff. So V4 by V3. That I will write here. V4 by V3. And it is constant volume. Apply ideal gas equation. P3, V3, T3. P2, V2, T2. You can ask a question why you are applying this equation, because it is a 2 to 3 process. 2 to 3 constant volume. Or you can apply P3, V3, T3. Cutoff ratio is point number 4. P4, V4 divided by T4. This is how. And it is constant pressure. So P3, P4 get cancelled. So V3 by V4 I can write as T3 by T4. V3 by V4 I can write T3 by T4, that is 1 by rho. Yes, students, here T3 is known, T4 is also known. Substitute here, calculate cutoff ratio, that you substitute here. Okay, then calculate T5. I will write here T5 is equal to T4 by, let me take new pen. Okay, T4 by T5 is equal to V1 by V2. What is V1 by V2? That is compression ratio. 1 by rho. This value is I will write like directly. I will write T3 by T4. 1 by rho is I will write T3 by T4 to the power of 0.4. So only unknown is T5. So how will you get? How much will you get T5? Approximately it should be less than T3 and T4, but it should be more than T1. So I will write 656.4 Kelvin. This is the value of T5. Please cross check your calculator and process. I hope all of you are writing the solution. Now, once you calculate all the temperatures, go to the previous equation, equation number 1. Here, this is efficiency of dual. This is efficiency of dual equation. You substitute all the values T1, T2, T3, T4, and T5. CV and CP value, it is right in terms of gamma. Okay. Otherwise, remember how much is the value of CP? That's what I told you in the previous classes. CP is 1.005 into 10 power of 3. CV is 0.718. So substitute all the values and efficiency of the dual cycle will be calculated. So the efficiency of dual cycle using equation number 1. So from equation 1, efficiency of dual is I will get 64.9. So this equation is in terms of T1, T2, T3, T4, T5, and we know CV value, we know CP, and CP by CV value is 1.4. So this is efficiency of dual cycle. Okay. or else you can calculate using one more method. That is, I told you, no, big equation 1 minus, you remember that equation, efficiency of dual cycle in terms of cutoff ratio, in terms of compression ratio. That is big equation, no? We told in the previous classes. So use that equation and we can calculate. Okay. So running out of time. So any doubts, sir? If you have any doubts, please ask me in the WhatsApp group so that I will be responding you. Okay. Or else you can comment in the video section. I will be responding you. Okay. So tomorrow class, we will start the new chapter module 4. That is Brayton cycle. Okay. So thank you so much for attending today classes. So today we'll take only 45 minutes in the first class. Tomorrow onwards, tomorrow we have two classes. We'll take two classes. Okay. So thank you. Thank you so much for attending this class. Bye bye.